came across the quantity which is called the covariance of X, which is given by the formula covariance of, and it only is applicable to a bivariate distribution. For univariate distribution, it doesn't have any meaning. So the formula, we have got two formula for covariance of X. One is given by expectation of X minus EX, and its product is taken with Y minus EY. We consider its expectation, or an operational formula that we can always use is the following: expectation of XY minus expectation of X into expectation of Y. So this is the formula for the covariance. Very important point to be noted is the following. Suppose the two variables that you are considering, X and Y, they are independent. Okay. If these two variables are independent, then we can easily show that expectation of XY is actually expectation of X into expectation of Y. As I told you that it always not happens, but for certain special cases it happens. So this is the scenario. If the variables are independent, this happens. And consequently, for independent variables, covariance of XY is actually becoming 0. It's a very important fact. You just note it down somewhere. Okay, so this is the first point that I wanted to talk about. We can also denote the covariance by this quantity. Now I'm going to write something very quickly. Now some sort of unitary method. So you see that what I'm actually writing. So you applying the unitary method, we can state the following. What we are stating: for each variation in the random variable capital X, there is a variation in capital Y given by the term which is called sigma Y. You know that sigma Y is actually standing for standard deviation of X, which is the positive square root of the variance. It is the standard deviation of Y. Similarly, sigma X is the standard deviation of capital X. So I'm writing it in, I'm putting it in this manner, that for each variation in the random variable X, there is a variation in Y given by sigma Y. So consequently, for sigma X variations in X, the variation in Y will be, sigma X into sigma Y. Okay, this is the first thing that I want to write. This is number 1. Now, for sigma X, sigma Y variations, the mutual deviation of X and Y is actually given by sigma X, sigma XY, that is covariance of XY. It is the formula, you know, to calculate the mutual deviation. So for each deviation of this quantity, sigma X into sigma Y, for this number of variations, mutual deviation of XY is calculated by the tool which is called covariance XY, and therefore for one variation, the mutual deviation of X and Y would be sigma XY by sigma X into sigma Y, or we can write it as covariance XY by sigma X into sigma Y. It is a kind of ratio. That we have calculated, and the ratio is defined in the following manner. Okay, This ratio is actually called, has a special name for bivariate distribution, or bivariate distribution with two variables x and y. The ratio sigma xy by sigma x into sigma y, or covariance xy divided by sigma x into sigma y. This is denoted by, this ratio is denoted by r of x comma y, or sometimes in some books it is written as rxy, and it is called, this ratio is called Karl-Pearson's correlation coefficient. It is called Karl-Pearson's correlation coefficient. It's a very important quantity, and very, I mean, whenever I'll be discussing correlation coefficient in details in module 4, you will get to see that this is not as easy as it seems to everyone. It is quite difficult concept, difficult to digest, but easy to calculate. This is the best part of correlation coefficient. Now, so say for example, actually the thing is that what correlation coefficient is actually measuring. The correlation coefficient is actually measuring the how much rxy is actually measures how much x and y are correlated with one another, So it is actually giving you a kind of quantification. It is a quantifiable quantity. This, you can measure this quantity, how much the two variables are correlated to one another. If one variable is changing, other variable is changing, how much correlation is there? This is the quantification formula. This ratio can be found, and this is called the correlation coefficient, or Karl-Pearson's correlation coefficient, in which covariance play a very important role. And just if I go back to my previous page, you see that this ratio has been defined. If you can remember the whatever I have written over here, the unitary process by which this ratio has been calculated, you will understand that why actually the correlation coefficient is giving you some sort of quantification. Before I end my today's session, a very quick thing that I can ask you to do by yourself at home is the following. Suppose a very easy homework that I'm going to place over here. Suppose I am taking a kind of bivariate distribution of the form which has only four variables in it. Say for example, and suppose this is the distribution. You can easily see that the value of y is actually obtained by this formula, x plus 1. Okay, very easy distribution I have chosen over here. Now your job is to calculate rxy, the correlation coefficient between the two variables. Okay, and you can take the help of this covariance formula. But if you are thinking about the expectation kind of thing, you can take the help of this quantity, because you know that this actually calculates, is similar to the expectation formula. This is 1 by n summation xi minus x bar yi minus y bar. Frequency term will not be there because frequencies are not there, and this will give you covariance xy. Or you can do one thing, you can okay, it is better you use this formula. Operation formula is only meant for expectation. If you use it, what you are going to do, you are going to make a chart. So in the chart you will put your xi, 4 values are given, yi 4 values are given. Then you are going to calculate from this chart, you are going to calculate x bar, you are going to calculate y bar, and then you are going to find the difference of each point xi from the point x bar. Some values will be positive, some values will be negative. And similar thing can be done by for the variable yi. Some variable will be positive, some variable will be negative, or all of them can be positive or all of them can be negative. And after this calculation, you can take the product of these two quantities, xi minus x bar and yi minus y bar. So product will be calculated. And after this, you are going to calculate the summation of this column, and that summation will be divided by the number of terms. How many terms are there? How many observations are there? There are n observations. 4. So in this manner, you can calculate the covariance xy. Then you are going to calculate sigma x square. Sigma x square, you can use this operational formula, or rather I must tell you that you use this formula, xi minus x bar whole square, because you have already xi minus x bar. So it would be easy for you to calculate you introduce another column, xi minus x bar whole square. Okay, and then you can take the summation of that column, you divide by n, and similarly you can calculate variance of y by this formula. After you calculate all these things, you just put it in this particular correlation coefficient formula and try to find out what sort of value comes out of it. My prediction is that you are going to get a value which is +1. It is my prediction. I'm not going to tell you that how did I predict it, but it is I'm very much sure, 100% sure. Very much means I'm 100% sure that if you are not doing mistakes in your calculation, you are going to get a correlation coefficient of 1 over here. So answer has been provided to you, method has been provided to you. You are going to calculate the correlation coefficient and try to verify by yourself. In the next class, that means tomorrow I'm not going to take any class because tomorrow is the exam day. My next class will be on next week, which I will be taking from my native town, because I am traveling on Sunday. Right now I am actually using a 5G connection, so speed is okay. But once I get over there, I have to rely on my old Geo modem that I was using previously. I hope that there will be no trouble, because some sort of trouble was there with my laptop, so it has been taken care of. So next class will be taken from my native town Assam, and hope to meet you soon, and I best of luck for tomorrow's examination. Tomorrow the question paper will be posted in the Google Classroom in my class timing 8:40, and then you will get all the instruction in the Google Classroom. Don't worry about it. You have already got the instruction. Only submitting Google form will not do. You have to upload your answer script also. It is the requirement from your department. It is not my requirement. So please make sure that you have submitted the Google form, as well as you have uploaded your answer script in the Google Classroom. So I'm asking all the CRs, please take care of it, and please convey the message to students who are not present in today's class. So with this, I'm going to conclude my today's session. In Google Classroom, my God, initially I didn't understand what GCR is. Google Classroom